be Jocelyn Gonzalez, and today I'm going to talk about the X-ray tube characteristic, the anode Hill effect, and the damage to the X-ray tube. We are going to start for the X-ray tube. The X-ray tube function is to convert energy into X-ray radiation and heat. 1% is going to be X-ray radiation and 99% heat. Some characteristics of the X-ray tube are the X-ray tube housing. This one is going to protect the X-ray tube from physical damage and insulate the tube electricity. This is going to help to protect the radiographer and patient because also it's covered of lead. This absorbs any of focus radiation. We also have the glass envelope. The glass envelope is made from Pyrex glass because it can withstand large amount of heat. This means they also can absorb the heat and create and maintain the functions. This creates the vacuum to increase the efficiency and productivity of the X-ray. The vacuum helps to the electron from the air to not contribute to the electron stream, which will disrupt the X-ray production process and damage the tube. Cathode. The cathode is the negative part of an X-ray tube and serves to expel the electron from the circuit and focus them in a beam on the focal spot of the anode. It is a controlled source of electrons for the generation of X-ray beams. The Focusing cup. The focusing cup is negative charged and is made of nickel. It surrounds the filament to condense the electrons into a beam of electrons that can be accelerated toward the anode. Without the focusing cup, there is a spread of electrons caused by electrostatic repulsion that minimize the efficiency of the X-ray tube because not all the X-ray produced will be emitted. We also have the filament. The filament is made of tungsten. It's heated by a small amount of current that flows through it. At a certain temperature, the electrons are boiled off the filament, a process called thermionic emission, to produce a beam of electrons. The anode. The anode is a positively charged electron that consists of the tungsten target, copper block, and coolant. The anode receives the electron emitted by the cathode and dissipates the heat created during the process. Also, depending on the kV kilovolt rating, the velocity at which the electrons are accelerated will vary. An increase in kV means an increase in acceleration of the electron from the cathode to the anode. The window. The window of the X-ray tube typically is made from beryllium because it allows X-rays to pass through but has sufficient strength to hold the vacuum required for the X-ray tube to operate. Anode Hill effect. It is a variation of the intensity of X-ray emitted by the anode depending on the direction of emission along the anode-cathode axis. Due to the geometry of the anode, X-rays emitted toward the cathode are in general more intense than those emitted perpendicular to the cathode axis. The effect stems from the absorption of X-ray photons before they leave the anode in which they are produced. The probability of absorption depends on the distance the photon travels within the anode material, which in turn depends on the direction of emission. Some damage to the X-ray tube are arcing, melting and pitting, and cracking. Arcing. When the tube arcing occurs when there is a short circuit within the tube, typically from the cathode to the tube envelope. The result is a temporary loss of X-ray output and a localized artifact. Melting and pitching. Melting and pitching occur when the temperature of the anode during a single exposure is excessively localized. These surface irregularities lead to a variable and reduced radiation output. If the melting is severe, the tungsten vaporizes and can plate the port. On some occasions, this can cause added filtering of interference with the flow of electrons. The cracking. If the temperature rises too fast, the rotation can become unstable, and this can cause cracking in the X-ray tube. So it is preferable not to apply maximum technique of MAS or KVP when the anode is cold. Thank you for the attention.